So, in this video, we are going to look at standard form. In other words, scientific notation. This is a very simple and straightforward concept that you need to make sure that you understand and know, because it comes in paper 2, ECZ Examination Council of Zambia exams. It comes in paper 2 and it carries 2 marks, 2 good marks out of 50. So let us observe to learn and understand it. Let's begin. Standard form. What is standard form? We are saying that standard form or scientific notation is a way of writing large or small numbers in a short form. I repeat, standard form or scientific notation is a way of writing large or small numbers in a short form. To begin with, there are things that you need to know about standard form. What are those things? The number is written in the form of. So we are simply saying that the number in standard form is written in the form of a times 10 to power n. A times 10 to power n. This is another way, the formula that you need to master, where 1 is less or equal to a, meaning this a is supposed to be a number that is 1 or less or equal to a. This a is less or equal to 1, meaning greater than 0, and less than 10. So the number should be between 1 and 9. This a, there should not be any number greater than 10 or less than 1. There should be 1 or 2 or 3 or 4 or 5. Once you write a number, let's say 23 point something to power 10, just know you are wrong. As long as it's 23, it's supposed to be 2.3, then you know you are correct. Now we will see on the example. We move on to the next one. We are simply saying that standard form for large numbers. Now let's look at standard form for large numbers. So standard form for large numbers, there are things that you need to know. Number 1, we use the fact that multiples of 10 can be written as powers of 10. Okay? Now, how does that work? As follows. 100 is same as 10 to power 2. 100 is same as 10 to power 2. So in this scenario, we are simply saying that we go back to the formula, this formula. So if it is to power 2 here, it simply means that the number that is here, it has been rounded off. And the number of time we have rounded off to the number so that we reach to one number only, it is 2 times. Same applies here. We can say this is 1000. Is same as 10 to power 3. How is this 3 coming about? Look at this. When you round off this number to exactly 1, this like this one, or to look like this, it will be like this. We move from here, 1, 2, 3. So it will be 1 times 10 to power 3. So this now, it is the same as this question which is here with this formula. So you can write this in standard form in this manner. So we are simply saying that we use the fact that multiples of 10 can be written as powers of 10 as follows. 1000 same as 10 to power 3. 10,000 can be written as 10 to power 4. So this one in standard form, or to write it in this form, it can be in this manner where we have to move the decimal point is in front of this is in front of this number. We move it from here 1, 2, 3, 4. So it will be 1 times 10 to power 4. 1 times 10 to power 4. So this is the same as this one. So this is in standard form. Okay, so now let's proceed now to writing large numbers in standard form. Writing large numbers in standard form. Example number 1. Write each of the following numbers in standard form. We have 348. How do I write 348 in standard form? So keeping in mind that whatever I write, it should look in this manner, and despite the number, how big the number is, it should be reduced to 1 this side times 10 to power 3. So this number is so big. We cannot write, for instance, we cannot write 34.8 times 10 to power 2. This will be totally wrong, because this side we have 34. It's supposed to be only 3, a number which is greater than 1 or equal to 1 but less than 10. So in this scenario, we are simply going to round off these two, 3, 4, 8. So we are going to round off this one to the nearest whole number. So we move from this 0, 1, 2. So where we reach here, this is where we put our decimal point. So it will be 3.48. Okay, 3.48 to the nearest whole number. Then times 10. How many times did we move from here to there? We moved 2 times. So this will be to power 2. Okay, so this is how you write this number in standard form. This is in standard form. Also, when we come to this one, this is not in standard form. You cannot say times 10 to power 1. No, because this 48 is bigger than 1. And they said that there should only be a number which is less than or equal to 1, this side. Okay, and it should be less than 10. So we are simply saying this number is big. So we are going to move this decimal point to the nearest whole number. We are going to move it once, 1 there. So we have 4.86 times 10 to power. How many times did I move? 1 time. So this is in standard form. Okay. Then we move on to the next one. 3,000. I mean, to write this in standard form, we just have to round off this to the nearest whole number, which is going to be 1, 2, 3. So it will be 3 times 10 to power, how many times? 1, 2, 3 to power 3. Okay, so this is also in standard form. This is the same as 10,000, rounding off 10,000 to rounding off 10,000 in standard form. So this is the same as 3,000. Okay, so once we have understood how to round off numbers in standard form, we need now to move on to the second question, which will ask us to round off this number in standard form correct to 3 significant figures or 2 significant figures. So since we know how to round off numbers in standard form, now we should know how to write in significant figures when we are asked. Now, significant figures, we have learned about them and we have answered questions in the previous video. So if you have not watched the previous video, I would advise you to watch one so that you understand what significant figures is all about. So let's answer the first question. 4,608,00. We need to write this question, this value in standard form. So the first thing is write it in standard form before you write it in significant figures. So let's write it in standard form. We are going to move the decimal point from here, 1, 2, 3, 4, 5. So we have 4.60800. Okay, so when you look at this question which is here, how many significant figures are there? Okay, so this is, we have moved times 10, we write times 10. How many times did you move? 1, 2, 3, 4, 5. 5 times. So we write 5 there. But we need to write it in 3 significant figures. So we are going to count. How many significant figures are here? We have 1, 2. Remember, significant figures, we count from left going to right. So we have 1, 2, 3. So here where there's 3, we put a demarcation there. Okay. Therefore, we are going to have now this 8. We are going to leave. Is it equal to 5 or greater than 5 or less than 5? It is greater than 5. So we are going to borrow 1 and put there. So instead of it being 0 here, we are going to replace it with 1. So it will be 4.61 times 10 to power 5. So this now, my dear friends, is in standard form correct to 3 significant figures. As you can see, we have 4, 6, and 1. These are non-zero digits and they are significant. How many times did we move for us to reach at this point here? We moved 5 times. That's what we put there. Okay, so we move on to the next question, which simply says we should write in 2 significant figures. So let us write 4,608,00. So the first stage, write this number in 2 significant figures. So we are going to say 1, 2. Then we put a demarcation there. Is this 0 greater than 5? No, it's less than 5. So it will just be 4, 6. So this is in 2 significant figures, but not in standard form. So to write it in standard form, we need to move now. How many times are we going to move from here all the way to where the decimal point will be here? How many times we are going to move? 1, 2, 3, 4, 5. 5 times. So it will be 4 0.6 times 10 to power 5. Okay, so this now is in standard form. So don't move it from here. When you write it in significant figures, here we know there are two significant figures. Don't just round it off from here and say 1, and then you say to power 1 there. You'll be wrong because the whole digit is given there. Okay, so you use this digit there to know how many times you are going to round off. So with this now knowledge, let us now move on to the next concept of trying to round off numbers, okay, of small rounding off, writing in standard form for small numbers. So this was for large numbers. Now what about small numbers? How will it look like? Will the powers be the same? Something should be different. So let's look at that now. Okay, so the standard form for small numbers. What should you know about small numbers? We are simply saying we use the fact that denominators of multiples of 10 can be written as a negative power of 10 as follows. 0.1 is the same as 1 over 10. Now 1 over 10, this 10 is raised to power 1. In other case, in indices, you learned about this kind of a concept. When the power is negative, we always write it as a fraction like this. So in this case, this will be 10 to power negative 1, proving the statement of standard form. Then we move on to the second one. We have 0.01. This is same as 1 over 100. So 1 over 100 can also be written as 1 over 10 to power 2, which means that the same as 1 over 100. Now in standard form, this can be 10 to power negative 2. Okay, so it goes on just like that. Now let's look at the example quickly. So we look at the example. The first example is asking us to write each of the following numbers in standard form. So we're going to write each of these numbers in standard form. To begin with, this number which is here is 0.24. To write it in standard form, we should always remember the concept of saying any number we are writing in standard form, it should look like this one. This is the format. This is what we know about standard form. This number which is here is is equal to 1 or greater than 1 but less than 10. Okay, and this n simply stands for the number of times I moved the decimal point. So in this scenario, we are simply saying that if I write 0.24 in standard form, I'll move this decimal point to 1 because this is 0, and they said that there should be a number 1 or greater than 1 but less than 10. Now this is 0, so I cannot say times 10 to power a number. No, it will be wrong. So in this case, I'll move this decimal point 1 time. So I'll have 2.4 times 10. How many times did I move this one? 1 time. But because it's a small number, it will have a negative what? Power. So it is going to be negative 1. So 2 to power 4 times 10 to power negative 1. Every time you see a small number like this one, to write it in standard form, just know that the power will be negative. But a big number, the power is always positive. So let's try to answer this one as well. 0.00643 in standard form will be, we move this decimal place how many times? 1, 2, 3. So the decimal point has moved 3 times. So it will be 6.43 times 10 to power negative 3 because it has moved 1, 2, 3 times. So this will be in standard form as well. So this is how you write small numbers in standard form. They should always have a negative power. And this side, you should always make sure that there's a number greater than 1 or equal to 1 but less than 10. Okay. Now, let's look at the second example. The second example is asking us to simply write 0.00000463352 in standard form, correct to 2 significant figures and 3 significant figures. So we're going to write this number. Let's write it here and see 0.123454635 and 2. Now, to 2 significant figures, we should always round off how many times should we move the decimal? Remember, these zeros are not significant. So it means that we cannot count them. The significant values start from 4, 6, 3, 5, 2. These are the significant numbers. So we are going to move the decimal point in standard form, correct to the number of significant figures being asked, which is 2. So let's move the decimal point. 1, 2, 3, 4, 5, 6 there. So it will be 4.635 2 times 10 to power negative 6, because I've moved 6 times. But how many significant figures did they say? 2. So we're going to count. How many significant figures are here? 1, 2, 3, 4, 5. But they just want 2. 1, 2. So we'll put a demarcation there. And therefore it will be, look at this 3. Is this 3 equal to 5 or less than 5? It is less than 5. So I cannot borrow 1 here. So we're going to just write 4.6 times 10 to power negative 6. So this is according to is in standard form correct to 2 significant figures. Same applies with this question. In 3 significant figures, you're just going to write the whole question 0.12345463552. So they are saying in 3 significant figures, these zeros are not significant. So we are going to move the decimal point. 1, 2, 3, 4, 5, 6 there. So it will be 4.6352 times 10 to power negative 6. A small number will always have a negative power. So how many significant figures? 3 significant figures. So 1, 2, 3. So we put a demarcation there. And now we can see that this 5 is equal to 5, and we can get 1 here and put there. So it will be 4.64 times 10 to power negative 6. So this is in 3 significant figures and in standard form. So this is how you write questions in significant figures and in standard form. So this marks the end of standard form, or approximation and estimation. Hopefully I've made this clear, and I believe that if this kind of a question comes in your exam, you will be able to answer it correctly without any problem. So just remember these concepts. They are very important and very helpful. Each and every day you are about to answer the questions, remember these concepts. Thank you for watching. We say bye-bye for now.